All right, so today we're going to start the next module, which is file input and output, file I/O for short. And today and probably Monday, we're going to run you through the basics for file input and output. But before we do that, let's go ahead and talk about what files are, because usually when you think of a file, you think of like a text file or a Word file or an Excel file sitting somewhere on your hard disk, and that is that is a file. But other things are files, right? Typically, we only think of a file on disk, but files are also a whole bunch of other things. Files are directories. They are programs are files. When you've got an executable file sitting on the system, that is a file, but when it's running, it's also a file. Buffers and sockets. Sockets especially are something that we're not going to cover directly here, but you are going to use implicitly. When a computer needs to talk to another computer over a network, how do they talk? They open up what's called a socket, and that's a connection between those two computers. Well, how do they actually send data back and forth? The socket is nothing more than a file. So to send data to this computer over there, all I'm doing is taking the socket and I'm writing to it. I'm writing to the file. I'm doing file output. On the other end, to receive the data, they're reading that file, okay? So file, everything in computing is basically a file. Files can either be read or they can be written to, meaning file input or file output, okay? Files can also be binary, which is pure data, or they can be plain text files, which is ASCII text data. If you are dealing with binary data, then bring in a library to do it. You've already done this, or we did it for you, I guess. When you went to process a bunch of image data, right? We brought in the STB library or whatever to take a raw binary file that represented a PNG file or whatever, and then had a C representation of that, and also to save the file out to a new PNG file, right? Plain text files are what we're going to focus on here, because we're really only going to do ASCII text processing. Because if you do have binary data, bring in a library to do it. Even if you have plain text data, right, it might be structured or not, but not intended for human consumption. We saw a couple of examples of this already: CSV files, XML and JSON files. We looked at examples of those last time. Another one is base64 encoding. Base64 encoding is when you've got a protocol or a channel where you're only sending text, but you want to send, say, an attachment. Email is a prime example here. SMTP, the Simple Mail Transfer Protocol, that is entirely text-based. And so what happens when you want to send somebody an image over as an attachment over email? What happens is you take that file, that pure binary file, that binary data, and you encode it in base64. We all know what base 2 is, right? 0 and 1, binary. We all know what base 10 is, or 10 fingers and 10 toes, 0 through 9. We've also seen hexadecimal, which is base 16, 0 through 9, but then also A through F. And over here in base 64, that expands it out to 64 characters. A through Z, uppercase and lowercase, that gives me 52. 0 through 9, that gives me 62. And then there are two special characters, I forget what they are, but so let's say equal sign and a tilde or something. And it takes that data and it simply just transfers it into a collection of those characters. You can actually do this online. We did it this morning. We're base 64 encoding online. And you can see what it looks like. I'll just take this text right here and put it right here. And if we were to encode that, then that's what it would look like, right? It's just a bunch of garbage for us, but for a computer, if you know how to decode it and encode it, then on the other end, you can decode it, and that's what your image would look like on your email client. That's what's happening in the background anytime you go to Gmail or whatever, or Outlook or whatever you're looking at, right? If you actually looked at the raw data that your email came through as, you'd see that the attachment has a bunch of these characters there, right? And that's how it actually got to you, okay? But again, we're not going to focus on that. Those are all for what are called EDI, right? Electronic Data Interchange. When you've got a system written in, say, C# and using a Microsoft stack, and it needs to talk to a server that was written in Unix using C, right? The way that you do that is by transmitting data in one of these universal formats, XML, JSON, Base64, right? That way that the systems don't have to know how to, speak each other's languages as far as C#, C, C++ goes. Instead, they're just exchanging data back and forth, right? All right, so we're going to focus on plain text data files, basically. There are 3 steps that we need to follow. 1 is that we need to open up the file. 2 is we process the file, do whatever we're going to do with the file. And then 3, we need to close the file. This is like a memory. If you allocate memory using malloc and then you use it, right, and then you need to get rid of it, you need to clean up after yourself using free. If you don't, then you have this leaked resource. With files, it's even worse, because if you don't close the file, there's a slight chance that it could be corrupted, right? And that you won't get if you're outputting to a file, it might not all have made it. The entire file might be lost, right? A whole bunch of things could go wrong if you don't properly close the file. So let's focus on step 1, opening a file. In C, files are represented using a pointer, right? And in this particular case, it's called file star. That is all uppercase, represented, right? All uppercase, and it's built into the I/O library, stdio. So we've already been including that, or it might be an stdlib, I forget. But it's already there for you, right? To open a file, use fopen, right? Or fopen, right? The F stands for file, open stands for open. Pretty straightforward. It takes 2 arguments. The first argument is a string that gives the file path plus the file name. Right? So you can open files up anywhere on the system that you want to, including the current working directory. And then the second is going to be the mode to open it up for, right? And there are 2 modes that we're going to look at. There are many modes, but we're only going to focus on 2. R, this is for reading. In other words, file input. Right? And then, what do you think the other one is? W for writing, right? Writing, this is file output, okay? Upon success, fopen will return a pointer to the file, right? We call this sometimes a handle, right? The pointer will point to the beginning of the file. As you read or write characters or bytes, however you want to look at it, the file pointer will automatically advance. So I'll show you how you can read character by character, but if there are 5 characters in the file, then initially it's pointing to the first one. When you read that, then it's now pointing to the second one. When you read that one, now it's pointing to the third one. In other words, it advances through the file automatically for you. Okay? Let's come over here and try to open up a file. All right? So I need a file pointer, F. Now you can call this F because it's a file. You can call it in if it's an input file. You can call it out, right, if it's an output file. Let's go ahead and do an output file initially, and so I'll call it out here. Okay? I'm going to call fopen. Now I'm going to want to open up a file, say in the current working directory, file.txt. And I'm going to want to, if it's an output file, what mode should I be using here? R or W, read or write? W because it's an output file, okay? Now what I generally do is anytime I open the file, before I start writing any other code, I immediately jump down and write code to close the file. And if fopen opens it, fclose closes it. There we go, out, okay? All right, let's just go ahead and run it as is. I'm not doing anything with it yet. All right, so gcc demo.c, there we go, and a.out. I'm not actually, outputting anything to the file just yet. Now remember that sometimes you got to kick VS Code here in the code spaces with a refresh over here. Do you see now that it created this file.txt over here? I never actually wrote anything to the file though. So when I open it, guess what? It's empty. That generates stuff. That's just the IDE telling me that it's an empty file. If I did an ls to list all the files, there it is. There's file.txt. If I listed anything about the file, I'd see that it was created about 1 minute ago, and it has a size of 0 bytes because nothing's in it. It's an empty file. But it's still a file that exists. All right? So my first observation here is opening a file that does not exist may create it for you, right? Okay, and in fact, in this case, it did, because it was an output file, right? Opening a file that does not exist for reading, however, let's go ahead and see what happens there. Okay, so let me come over here and let's go ahead and change this to an input file. And if I'm doing input now, it's no longer reading or writing, it is reading. Okay, and let's go ahead and go with a file, some file, right? Some file.txt. Okay, and then we'll close it. All right. In. Now that it's an input file, gcc a.out. Right. Segmentation fault. Right. What happened here? Right. Well, first of all, does some file.txt exist? No. So, Fopen fails. In the event of a failure, it can only return a pointer. So what pointer value have we now expressed at least a dozen times to indicate something went wrong? Null, right? So in the event of failure, it's going to return a null pointer. If in is equal to null, then we can to do error handling, right? To do error handling. But that's my next observation. That opening a file for reading that does not exist is going to be an error. Fopen will return null in that case, N-U-L-L. There we go. All right. Something else could go wrong. Opening a file that you do not have permission to read or write, ... Let's find out what happens here. All right. And the classic example that I'm going to go to here is the etc password file. So etc is short for etc, but we pronounce it etsy in the Unix world. And then there's this file in that directory in any Unix system called passwd. What do you think it stores? Or it stored at one time? Passwords. In fact, let me come over here and show you the contents of it. Right? Oops, clear. More etsy password. There we go. Now, at some point, it did store passwords, but they've been, since a long time ago, they've been redacted. I can read this file. Do you think it's a good idea to allow me to write this file, though? Probably not. So let me go ahead and add some, let me go ahead and actually change this to F because I don't want to keep going back and forth there. All right, so let's see if it worked. If F is not equal to null, right, then printf opened the file. Yay, we did it, right? Otherwise, else, printf opening failed, end the line, right? So let's see if this actually works. Remember, I'm opening it up for reading, but I could read it down there. I have permission to read it because at some point they removed the passwords there, right? So, open the file successfully. However, do you think that I should be able to write to the file? Nope. Let's see if I have permission to do that, right? Opening failed and segmentation fault because we have that null pointer, and down here when we try to close a null pointer, then a seg faults out, right? So, opening a file that you do not have the permission to read or write, right, will result in null, N-U-L-L. There we go. Let me show you a file that I do not have a permission to read at all. So if let's go ahead and ls etsy password. There we go. Ls etsy, excuse me. Oh, okay, there's lots of stuff there. All right, ls etsy. I'll just jump to it. Come on, there it is. Shadow. There is called this is the shadow of that file. That's where the passwords are actually stored. All right. Now let me go ahead and just try to read that file and here more etsy shadow. Right. There we go. Cannot read it. So I can't read it. I can't write it. Right. If I do sudo though, let's see if I can do that. More etsy shadow. There we go. Yay! I did it. Right. And it looks like I mean, this is a fake virtual machine, so they're not real. I mean, there aren't any real passwords in there. But if you were to open it up on a regular old system, and you had permission to do so, then you would be able to see like passwords and encrypted passwords, right, or hashed passwords. You wouldn't be able to see plain text passwords. Hopefully, you wouldn't be able to see them. Right? But in any case, anytime that something happens, bad happens, an error happens, it'll result in null. Okay. All right. Let's go ahead and try to open up another file here for writing. Right. I'm going to make a huge mistake here. I'm going to open up myself. Right. So this is the demo file right here, and then I'll close it. Okay. And I'm opening it up for writing here. Before I do that, I'm going to copy and paste it to my clipboard here. Let's go ahead and try this, though. GCC a.out. What do you think is going to happen? So remember, I've got all this nice code there. Let's go ahead and close it out. A.out. It was fine. That file belongs to me. I have permission to read or write to it. I can do whatever I want with it. And guess what? It's gone. Right? There is no undo. Right? If you start reading or if you start writing to a file, that's it. The contents are gone, right? And that's why I copied them so that I wouldn't lose them, right? Okay. So, opening a file for writing that already exists will overwrite your data, okay? There's no undo there. Opening up a file for writing that does not exist will generally create the file for you, though, right? So, if you're doing a writing, that's fine. It'll create the file if it doesn't exist. If it opens a file for reading that does not exist, then you will have a problem there. We already jumped to the conclusion here, but step number 3, closing the file. Again, I want to emphasize that failure to properly close a file can lead to corrupted data, undefined behavior, etc., just loss of data. Right? Okay. Always close your file when you are done. Right? And as we said, use for close. But after it's closed, you cannot read or write from the file anymore. You basically have to reopen it if you want to do so. Okay? All right. All right, so that's step 1 and step 2, and we kind of glossed over the step 3. That's where the real work is done, of course. Step 3 being process the file. So since we're only opening it up for 2 modes, right, we can do file output or we can do file input. Let's keep it simple. There are dozens of ways of doing file output, and there are dozens of ways of doing file input. I'm going to only show you a couple because you're already familiar with them. To keep it simple, use fprintf. Now, you are already familiar with printf. What is the extra f standing in front of it? What do you think that stands for? File. In other words, you're not printing to the standard output, but by the way, the standard output is a file, right? But instead, you're printing to other defined file. The only difference is that you provide the file handle as your first argument to this function. Everything that you know and love, if you don't love or hate, everything that you know love or hate about printf can be used with fprintf. All of the same placeholders, all of the same problems, all of the same benefits, all of the same tips and tricks that we've given you for printf work with fprintf. Because at the end of the day, fprintf is doing nothing except printing to std out, which is a file, right? It's a file pointer, okay? So let's come back over here, and we're going to do this for writing, right? And I don't want to do demo anymore. Let's go ahead and do that file.txt. Now, if I wanted to print to the standard output, say hello world, right, and the line, then I would use fprintf, or I would use printf. But since I want to print it to the standard to this actual file that I've opened, I use fprintf, and I provide the file handle right at the front. So instead of the formatting being the first argument, now the file handle, the file pointer, is the first argument. You can do this with variables. Int x is equal to 42, int y is equal, or let's go with that double y is equal to 1.567, right? And char c initial is equal to q or something, right? Fprintf, again, you need to print to the file, and then you can use all the placeholders that you want. X is equal to %d for an integer. Y is equal to %f for a floating point number. And C, or initial, is equal to %c for a single character. So here, x, y, and initial. Right? Okay. I'm already closing the file, so we're good on that front. Let's go ahead and GCC this and run it. And let's open up that file and we see hello world and all the formatting that I specified. All right. What if I change this? What if I say goodbye world? All right. Recompile it and rerun it. All right. What's going to happen over here? Predict. It's going to overwrite everything. Right. A dot out. And there, it changed. All of my old data was overwritten. There are other modes other than reading and writing. There are modes like for appending or for other things. I think that I can't remember any off the top of my head. But in any case, you are overwriting your own data. Okay, so make sure that you know what you're doing there. Okay. All right. So let's go ahead and grab this and just this chunk of code right here, and in the notes, see, there we go. All right. So there is all you need to know about file output, for plain text file output, I should say. All right, so other items before we move on to file output. You can use relative and absolute file paths. For example, you can say fopen for foo.txt for reading, right? And this opens foo.txt in the current working directory. Wherever you're running the program, the same directory. You can use relative, right? So fopen, let's go ahead and go up two directories. Remember, dot dot will go up one directory, dot dot goes up another directory. Then we'll go down into a data directory, and then inside there we'll go ahead and open up bar.txt, right? So this is relative to the current working directory. That's another acronym that you'll probably want to memorize, CWD, right? Current working directory, right? Relative to the current working directory, 2 flights up or 2 directories up, and then down into data and opening bar.txt in that directory, right? You can use absolute paths, and we've already seen an example of this. You can use fopen and then start at the root, in quotations here, you can start at the root and say, in the etc directory, let's go ahead and open up that password file for reading, right? Okay. So you can do current working directory, you can do relative, you can do absolute paths, right? All right. Good. And yeah, that's good enough, right? File input. Okay. There are many ways to do file input. Most are dangerous. Right? They're dangerous in that it's susceptible to buffer overflows. Ultimately, what you're going to be doing when you do file input is you're going to be reading some data from a file and you're going to have to store it somewhere. Where are you going to store it? In a buffer that we call strings, right? And therefore, you're going to have a string big enough to hold whatever you're trying to read from the file, right? So there are ways of doing that, but there are dangerous ways of doing that by just simply, just read whatever and then try to fit it into the string. I don't care about the size, right? We're not going to do that way. Instead, I'm going to show you 2 safe ways. Safe ways in that they are limited. The first one is fgetc, and it reads 1 character at a time. Get the first character, get the second character, get the third character. And then fgets, that stands for file get string, and it reads an entire line up to an entire line at one time. Okay? And both of these are going to be safe because of how you use them and how they're designed. Let's go ahead and start with the easy one first. fgetc reads 1 character at a time. It starts at the first character. After each one is read, right, it advances to the next character automatically, right? That, in other words, this file pointer is updated, right? Okay? You don't have to do anything with it. It'll automatically update it to the next byte, the next byte, the next byte, until it reaches the end of the file, right? How are we going to tell that we're at the end of the file here, right? To determine if you are at the end of the file, a special character is defined called EOF. Now look really, really hard at that ASCII text table, and you will never find this, because this is not an ASCII text value, right? It's not the null terminating character. It is not 0. It is not the end line character. It is not a character at all. EOF stands for end of file. And in fact, if you look at what EOF value has, it probably has a value of -1. That is nowhere found on the ASCII text table because it's a special flag value indicating that you've reached the end of the file. Right? Let's go ahead and play around with it up here. Right? So I'm going to go ahead and open up that file like this, the same file here, but for reading now that I've created that file. Let's go ahead and get the first character. So I need a character C, right? And I will go ahead and call fgetC, okay? And all I'm going to do is pass in that file pointer, that file handle. Let's see if we read that correctly. Printf C is equal to %C and the line C. Right? And let's go ahead and do this over and over and over again for a few characters. And I can't redeclare the variable, so I'll get the first character and print it. Get the second character and print it. Do this again several times. Third character, fourth character, fifth character. GCC this. And let's just see this in action here, right? Remember that the first word was goodbye. So it got the first character, and then it automatically advanced that pointer over to the second character. Then the third character, the fourth character. Every time I called fgetC, it automatically went through the file for me, right? Now I could have cut and paste this a million times if I want, not a million times, but however many characters are in this file. But I don't want to do that. Right? Let's go ahead and design a loop to do this for us, character by character. All right? I'll go ahead and get the first character. All right? Do we know how many characters are going to be in this file up front? At least inside my C program right here. I of course can look at the file lsla and see that file.c. There are 48 bytes in there, meaning that there are 48 characters, right? But that doesn't work for every file. So what kind of a loop do you want to write here? A for loop or a while loop? While. I don't know how many characters I'm going to encounter up front, so I'll just go with a while loop there. And let's move this functionality into my while loop there, all right? Get rid of all that. All I'm going to do is print out the current character, then set myself up for the next iteration of this to get the next character. Now, what's going to be my stopping condition here? While I'm not at the end of the file, while f is not at the end of the file, ... right? Well, it will return EOF as my return value here once I hit the end of the file. So C is not equal to EOF. Right? Let's check out that EOF before we actually test this. Right? I was right. What value does it have? 0. And if you go to the ASCII text table, ASCIItable.com, right? Where does the numbering start? At 0, and then it goes up. There are no negative values here. This is not a character that you can actually find in the table. It's not a character that you can print either, right? I'll show that to you here in a second. But instead, let's go ahead and see this working. GCC and run it. There we go. All right. So all the way at the top here, goodbye world. X is equal to 42, blah, 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 blah. And then we get down to the end here, Q. Was Q the last thing? Yeah, Q was the last thing. Actually, what is the last thing right here? What's implicit at the end of this line? The end line character, the /n. And that's what's getting printed right here, right? It's not actually printing anything. Instead, it's going to the next line there, right? All right, so let's come back over here. You know what? Just to find out what happens if you try to print the endline character, the EOF character, printf %EOF question mark, and I'll go ahead and try to print it as a character there, and the line EOF. GCC this, and there. What is that thing right there? That's my terminal's attempt to print a non-existent character, right? You might also have problems if you use emojis or something like that and you try to print those out. Certainly if you have corrupted data, right, and it ends up being a signed integer or something like that, you might see this on the grader as well, right, if you've got corrupted data, right? So that's a huge red flag there that something went wrong, right, because it can't figure out how to print that because it ain't a character, right? Okay. All right, so let's go ahead and get rid of that. Let's also make sure that we were actually correct here. Let's go ahead and set up a counter. Int count is equal to 0. Every time I count a character, I will increment this counter. And at the end of this I'll say printf found %d characters. I want to know if I read every single character correctly. So let's go ahead and print this out. GCC and run this. 48 characters. Do we remember how many characters there were? lsla file.txt, and it was of size 48 bytes, and each byte is a character. So yeah, it looks like it to me. There's another tool that you can use at the command line called WC. That's short for word count. And if you ask it about a file, it'll report actually multiple things. There are 2 lines in the file. There are 11 words. And by words, it just means things followed by white space, interleaved with white space. And then finally, 48 characters in that file. Right? You could also cut and paste it and put it into an online character counter or something. Right? But I have high probability here that I've got I have high assurance here that I'm reading every single character correctly. Right? How could we put that into a string for later processing? Ideas? In other words, what I want is char star file contents, right? Something like that, right? And this is what you'll be doing in your hack next week, but let's outline the idea, right? So at this point in the program, I know how many characters there are, right? Right? We know there are count characters in the file, right? Actually, let's close it, right? And then so if I know how many characters are in the file, then what could I do? 1, declare or create a string big enough to hold the entire file. Right? How big is that going to be in this case? Remember, it was 48, but 48 plus 1 for the null terminating character, right? We all know how to do that because we've done strings now. 2, right? Reopen the file and read character by character, filling the string, if that's the way that you want to do it, right? And then 3, what? What's always the third step? Close the file, because you reopen the file, now you need to close the file, right? Oh, and also maybe 2.5, take care of the null terminator, right? Okay. So there's an outline of what you're going to do in your hack next week. Okay. You'll once you've got it, you read it from a file. You've got just one big giant string, and then you can process it further if you want to. Okay. All right. I will take this stuff though, and put it in the notes so that you have it. Right. Feel free to work off of it if you need to. See, there we go. All right. Honorable mentions. Right. Let's go with like that. Yeah. There are other nice utility functions in the stdio library. Right. For example, there's fseek. Right. Okay. This can fast forward or rewind the file pointer. Right. There's also another function that just says rewind. Right. Rewind, it goes all the way back to the beginning. This rewinds. This rewinds all the way back to the start of the file. Feel free to read up on these and use them if you want, right? But what I want to do is I want to ask you about why do they use these words? Seek, rewind, right? Well, first of all, what does seek mean? Right? It means like fast forwarding or rewinding, right? Or back and forth, and rewinding, right? So think back to the 70s or 80s. Right? What computers stored data on what back then? Tapes, right? So I don't know, retro computer tape drive. Could I get a picture of this? Vintage computer tape drive, right? There, that's good enough. That looks really, really modern though. It says vintage mainframe, but it looks brand new to me. But that's what they did back in the 50s, 60s, 70s, right? And so if you were reading a file from an actual tape deck, what were you doing? You were fast forwarding, you were rewinding that tape. And by the way, it's still used to this day. That's more retro to me. There, that guy wearing his IBM outfit and probably a pocket protector or something in the front, right? And that's where data was stored. In fact, to this day, it's still being used. You can still buy tape drives and tape backups because per megabyte or per gigabyte, it's still the cheapest way to store data, right? I don't know. Can you get one on Newegg.com? Tape magnetic tape drive. No, internal tape drive, yeah, $3,500, and then you can get let's see, it looks like 45 terabytes for $2,000. No, that cartridge is probably what you want. How big is that though? $100 for how much storage there? It doesn't say. Oh, there, 45 terabytes right there. All right. So for 45 terabytes, only $100. $100 right now will get you what? 1 terabyte, maybe, like a flash drive, right? So, yeah, it's still the cheapest way of doing stuff if you want to. But it's no longer cheap if you have to maintain the hardware. All right, so let's come back over here. And let's go ahead and get rid of all that. But for close F. All right, so the other way of doing this, let's go ahead and come back over here. All right. You can also use forgets. All right. So forgets. Let's move out there. Using forgets. There we go. You can use forgets to get up to an entire line of input at once. Instead of going character by character by character, you can get an entire line at one time. Here is the signature of this, right? It will return a pointer to, we'll talk about what it returns here in a second. But there is where you are storing your data, S, right? Note here that there's no const keyword. You know that it's going to be writing to that string right there. There is a size parameter here that will limit the amount of data that's being read. And finally, the file input stream that you're reading from, okay? So again, the first argument there is a buffer. That is a string that you want the line read into, right? It's got to be big enough. If you have a line with 1,000,000 characters, no end-line characters at all, then you've got to make sure that that string is big enough to hold it, right? That's where the safety comes in. The second argument is the maximum number of bytes that you'll read into the buffer. -1. -1 because forgets will actually take care of the null terminating character for you. Nice and convenient. Okay. It'll actually stop when it sees the first end-line character, right? That first end-line character being \n, right? It's not going to see the null terminating character because null terminating characters are not typically in text files, right? Or it will stop after size bytes, okay? In which case it will add in the null terminating character for you. Still adds in the null terminator for you, okay? Okay. Upon success, it will return a valid pointer to the buffer, to the same buffer you just read into. Right? Upon failure or the end of the file, it returns. What do you think? What's the return type here? Char star, a pointer. Again, for the millionth time, what is the only pointer that indicates something else went wrong or something, I'm at the end of the file in this case, something aberrant happened? The only value is null. It returns null at the end of the file. Because EOF is actually just a character. It's just a number. It's not a pointer. Okay? All right, so let's go ahead and try it out over here. First thing I need is a string to read into. Right? For now, I'm just going to go ahead and use a static string, char, and I'm going to call it a proper name here, buffer. because that's what we're actually reading into, right? You know what a buffer is, right? If you've ever gone to YouTube, you've got it, and it's buffering, right? It's downloading data, and then you're consuming it as you go along. But there's always a little bit of ahead of it. That's called the buffer, right? That's where temporary data is stored before you consume it and then it fills up the rest of the buffer, right? And that's going to be my buffer right there. Then I'm going to call forgets. And remember the 3 arguments here. The string that you want to read into, the size, the maximum size, and the input file string here, or the input file stream, excuse me. Right. So buffer, what should I put for my size? And what should I put for my file? It's just F as before. Right, there we go. But what should I put for my size here? What is the maximum number of bytes that I should read because my buffer is 100 here? Normally 99, right? Right? But remember the behavior here. It reads at most 99 and 100 minus 1 because it will take care of that null terminating character for you. In other words, this number right here should always match the buffer size there. These 2 numbers should always be the same. It will read in at most, let's go ahead and get rid of that, at most 100 bytes. But are there 100 bytes in that first line? Nope. So what it'll do is it'll read until it sees that end line character, at which point it stops. And that's what gets read into the buffer. Goodbye world. All right? Let's test it. Let's go ahead and char star result is equal to. We'll come back to the result here in a second. Printf, and we'll say the line is equal to %s and the line of buffer. You can always also call it line if you want to, or line buffer if you want to do the entire thing. GCC. Let's run it. And there we go. Goodbye world. Right. Why is there a blank line right there? So, read. What is the character that it stops at here? The end line character. So what does that tell you about what's stored in that string? Right? It'll retain the end line character for you. Right? So another observation here. Forgets will retain the end line character in the buffer if it reads it. Right? If you want to get rid of it, ... How am I going to get rid of it? I don't want that inline character in there anymore. So buffer sub something is equal to, I can always set the last character equal to the null terminating character to get rid of it. Right? Where is the last character here? Question mark, question mark. So if it was just hello, HELLO, and then the inline character, where would that be? How big is this string right here? 6, right? Is there a function that tells me how big a string is? strlen of buffer. It's kind of weird using buffer within this in itself to do a index, but it's perfectly fine. Let's try that again. Right? Oops. Come on. Right? -1. There we go. Because this is 6, so 0, 1, 2, 3, 4, 5. Right? So we're off by 1. There we go. That's why. Right? Goodbye world. And now there's not a blank line there anymore because the end line character has been removed. Right? Let me prove it to you. Let me go ahead and surround this with double quotes. And we should definitely see that they're all taken out there. That's called chomping. You can chomp out the end line character. All right? Reset it to the null terminating character, right? And use a combination of strlen, right? Okay. Well, that's one line. Let's go ahead and do it again, right? There's another line. Result, okay? GCC this, and there are the 2 lines, and that's what's in the file, right? What if I did that a third time? Right? Now I'm trying to read 3 lines. Are there 3 lines in that file? Nope. What ends up happening here? Right? The buffer didn't get changed. Right? What happened with the result, though? Right? Printf, result is equal to percent. That's a string, so percent s and the line. And then we'll say result, GCC, a.out. The result is null. Right? That is your indication that you've reached the end of the file. Of course, the buffer didn't get changed here, right? Because it's still a string, whatever string was there before, right? But the result is now null. I'm going to have to use that in my loop to read this line by line by line. So let's go ahead and erase all of this, right? There we go. Get rid of that, right? And there we go. So once again, do you know how many lines you're going to read? Nope. So while some condition. Let's go ahead and move that up to initialize it. We'll go ahead and chomp it out. Actually, we'll chomp it out beforehand, right? And then let's print it out. And then we'll repeat the result, get the buffer. There we go. And there. There. And we can get rid of all the rest of this. Okay. So we'll go ahead and get the result. We'll chomp out the endline character. Then we'll go into our while loop here. We'll print it out, and then we'll get the next one. Let's also chomp that out, by the way, right? So that we don't have endline characters in there. Okay. What is my while condition here now? Remember that result will be null when you reach the end of the file. So while the result is not equal to null, keep going. All right. GCC this, clear this out so that we start from scratch. And there we go. 2 lines. Let's go ahead and change this so that line 3, line 4, line 5. Okay, done. Right. Save. It's automatically saved. Right. And I didn't have to change any of my code. I'm just changing what the file, the contents are. Right. Here's a good question. What if it's empty? Right. What's going to happen here? First of all, the file exists. Right. So Fopen will be successful. But the first time that I read it, there's nothing to be read. So the result is null. My loop will never execute. Right? But be careful. Right? Is this a valid null terminated string if I never read anything? Nope. But it's probably okay. At least in this case, it's not showing up as a bad thing. That's why you should always I'll always initialize your strings here. That will automatically put in a null terminating character for me. That is now safe, right? There we go. Right, and I'm still not reading anything. Can I do undo? Undo, yep, there we go. I've just restored it. And run this again, and now I've got my lines there back. Right. Once again, you're going to have to do this for your hack next week. Right? You're going to have to read it line by line, but you're going to have to store each line into an array. In other words, you're going to have an array of strings. The first one will be the first line. The second one will be the second line, et cetera, et cetera, et cetera. Right? And you'll be able to do it by using forgets and a combination of what we just discussed. Once you know how big it is, right, you can then create how many lines there are. Then you can create a two-dimensional array. Then you can go through each line. Well, now you know how big each line is, right? And then you can go ahead and create an array for that, right? All right. I don't know, counter as well, right? Int count is equal to 0, and then count plus plus, right? And then down here I'll say printf I read %d lines, and the line count. How many lines are in there, by the way? Looks like 6 to me. Yeah, I read 6 lines, right? So all you need to do is count things. All right. Any questions? No? All right. We'll do a little bit of a demonstration next time for binary files to get you prepped for your lab. But those are all the basics for file I/O.